Good day, this is Mr. Morales, and today I'll be explaining the process for finding the difference of squares. So first of all, we're going to do a quick review. We're asked to name some perfect squares. So perfect squares basically is any value times itself. So traditionally for this lesson, we're going to use whole numbers, whole integers. So perfect squares, 1 times 1 is 1, 2 times itself is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and you can continue the list on your own up to whatever number you believe you need. The idea is just to get the idea of what a perfect square is, a number times itself, or anything, really any value times itself. So let's get into today's lesson. Today we are going to look at how we factor perfect square binomials. And although it may sound complicated for some, it's actually quite an easy process. First of all, what we want is to make sure that we have the difference of squares, which means there should be subtraction going on. And here we have subtraction between positive numbers, so okay, we have our difference. Now, what we need are the two sets of factors that will give us the resulting expression above here. So if you just work from left to right, the process is pretty easy. What variable times itself will give us this a squared? Well, that would be an a times another a. So there's our first part of our solution. Now we need what number times itself will give us this term at the end. Well, we know we would get a 1 times a 1 gives us a 1. However, in order to get this subtraction symbol, we would need to have a positive version of that number and a negative version of that number. Now we have the two factors that give us a squared minus 1. You can go ahead and multiply them out using FOIL or distributive property. A times a is a squared. A times negative 1 is a negative a. Positive 1 times a is a positive a, and positive 1 times negative 1 is a negative 1. You'll see here that these a terms cancel out, leaving us with a squared minus 1, which is indeed our original expression. So let's go ahead and continue that pattern. To find 9b squared minus 4, what makes this different from the first one is that we have a coefficient of positive 9. But remember, we're just trying to figure out basically the square root of each term, or each piece of the term. So what's the square root of 9? What times itself gives you a 9? A 3 times a 3. What variable times itself gives you b squared? Well, that would be a b and another b. What number times itself gives us this last term, a 4? That would be 2 times itself. But in order to get a negative 4, we would need a positive version of that last term and a negative version. You can then go ahead and use distributive property again, FOIL, and you can get this. You could verify that you indeed have the original expression. Now let's work on number 3. Here we have, in this example, we have two sets of coefficients bounded with two variables. And the process is exactly the same again. What times itself gives us a 4? That would be a 2 times a 2. What times itself gives us x squared? That would be an x. What times itself gives us a 16? That would be a 4. And what times itself gives us a y squared? That would be a y. But in order to get the difference of those things, we would need a positive version and a negative version. Continuing on the same exact process, it repeats all over again below here in number 4. So what is the square root of 25? We would need a 5 and a 5. What is the square root of m squared? A single m in both of these answer sets. What is the square root of 64? That would be an 8. What is the square root of p squared? That would be a single p. In order to get the difference, I would need a positive version and a negative version. So, from these 4 examples, what patterns have you been noticing? There are several patterns. One of the big ones you should notice is what's happening here between the terms that I repeatedly said. Hopefully you'll write that down and explain to your teacher what patterns you have noticed. Continuing on with today's notes, we have on the bottom, we have 4 more examples. Now, after we've learned how to use the process, we need to know how to determine if a polynomial is a difference of squares and factor if it is. If it's not a difference of squares, then we just write prime because it's not factorable. So let's begin with number 5. Here we have 81s squared minus 4t squared. Our instructions ask us to determine if the polynomial is a difference. Yes, we have a difference of squares. So I'll go ahead and set up my factors. Square root of 81 would be a 9. Square root of s squared would be an s. Square root of 4 would be a 2. Square root of t squared would be a singular t. And in order to get the difference, I would need a positive version and a negative version of those terms. Moving on to number 6, 9b squared plus 4. Although 9b squared and 4 are all perfect squares, this is not a difference. Therefore, we can't factor it, and we just refer to this as prime. We can't factor it. It's unfactorable, non-factorable, excuse me. Number 7, 1/16 x squared minus 1/64 y squared. Don't let the fractions confuse you. To find the square root of a fraction, you square root the numerator. Square root of 1 would be 1. Square root of 16 would be 4. So that's going to be the beginning of my parentheses. Square root of x squared would be x. So I'll go ahead and set up both parentheses with that first term. So 1 over 16, square root of it is 1/4. Square root of x squared, a singular x. Apply the same process with the fraction for 1/64. The square root of 1/64 would be 1/8, because the square root of 1 remains 1, and the square root of 64 is 8. So I have a 1/8 on the right side. The square root of y squared would be a singular y attached to that. And in order to get the difference, I would need a positive and a negative version of that term. And now I have my solution. And finally, for number 8, I have 25a squared plus 36b squared. And if you notice, just like the example above, although all the terms and pieces, components of it, are all nice and perfect squares, this is not a difference of squares. So we just refer to this as prime, and we move on. So your your assignment for today is going to be page 36, and feel free to go ahead and get started on that. And if you have any questions, go ahead and ask your teacher. Thank you very much, and have a good day.